In this tutorial, we'll talk about 2D unconstrained optimization. And for this purpose, we will use a new function, which is a function of x and y. And as you can see, it's just an extension of the previous function that we did. We just have a y dependence. So we basically took the whole thing and we also created the same thing along the y-axis. And some of you may be able to visualize this, what this would look like in 3D. But to proceed, first of all, let's use the same approach that we used earlier to create a function in Matlab. So in this case now f is a function of x and y, and this is the relationship that defines that function. So I'm going to just copy paste this and run it. You should pause it and type it so that you can see how it works. And in a similar manner that we did before, now we can find the value of the function f at different values of x and y. We can also plot it, and for that purpose we use a function called EasySurf, which is for plotting functions. And we can put the function name, and that's the minimum number of arguments we need, or we can also specify the domain. In this case we can say that the x goes from -10 to 10 and y also goes from -10 to 10. So it will create a plot that will be within those domain values. And if you want to look at this plot from different angles, you can change the view angle by clicking this rotate 3D button, and your icon changes, and now you can grab the 3D plot and move the mouse around to look at it from different views. You would need this to find some of the plot points that you throw on this plot further, to make sure that you see where the minima and maxima are. Again, this is an interesting function because there are so many minimas and maximas, and we will do the unconstrained optimization on this to find where that minimum value is. So one other function that you need to be aware of is the easy contour. A lot of times it's just like in our natural terrains, we can get a feel of the terrain by just looking at the contours, and for that purpose, if you type easy contour, it will show you the contour map. Again, in contour map, the reds are high points and the blues are the low points. And if you want to further see what these colors mean, you can always put a color bar on the side and see what the values are. So clearly blue values are the negative values, and then 0 lies around this orange shade, and then red are the high values. So now going back to, again, surface plot, we are trying to find the minima, in this case unconstrained minima or minimum. So for that purpose, turns out for Matlab, function fmin unconstrained, and as a matter of fact all the other functions, you cannot provide it with multiple values of the variables. So if you want to create a multivariable function, you have to create it using vectors or matrices and not individual variables. So in order to do that, you have two ways to take care of it. One is you can create a new function that calls this previous mathematical function, or just define this new function to handle vectors. So for the sake of this lab, I have just created this new function f2, and I'm saying this is a function of a vector x that has two values, x1 and x2, and then I'm calling the other function with those two values, x1 and x2. And if I enter, I still have my old function, but I have my new function that depends upon this function. So if I call my first function, if you remember, f3 and 3 is -1.23, but I can call second function with giving the same values in a vector, and I will put these spaces so you can see that I'm entering this as a vector. So I'm putting those two values in a single element, and now I can use the fmin unc to optimize f of 2. Okay, so as you can see, it gives exactly the same value. So now I can run this code, and just like we did it before for 1D case, we are finding optimal value of x and the function value at that optimal point using fmin unconstrained. F2 is our function and 0, 0 is our starting point. And when we run it, it says your point is at minus 1.74, minus 1.74, and the value of the function is minus 4.54. And in similar way we did earlier, we can plot this point. We first hold on, and now we're not using the simple plot command, but we are using plot3 command because we have three inputs, x, y, and z. So this is x, this is y, and this is z. And when we run this, I'm putting this as a black circle. K stands for black and O is for circle, and it should show up somewhere on this plot. We can go back to this plot and we may have to rotate it to find our little dot. So if you just move it around, you can see that there's a little circle which is at minus 1.74 and minus 1.74 values of x and y. So this is how you can run an unconstrained minimization in case of 2D. To complete this part, we should also see how this point would look like a contour map. So first of all, let's hold off so we can create a new plot, and then we do an easy contour and plot it. So now we have contours, and again hold on and plot this. Now we're not doing a 3D plot, so we'll use our regular command with x and y coordinates, and it appears right here. So this is our minimum for this function, close to our initial point. You should try running this code with different initialization values and see how this program will find a different value of the minimum, which is of course a local minimum around the vicinity of your initialization point. So this concludes our tutorial for unconstrained optimization for functions in two variables.